So, good evening, all. Today's topic is going to be 8.5 Equations of Motion by Graphical Method. Okay, so that is the topic we are going to understand. It's very simple to understand, but problem is that in every exam, at least one question is asked based on this. So, I will also tell you what kind of question is asked, and you do this topic very seriously because if a question is asked from this topic, it would be at least for 3 or 4 marker. Okay, so it would be a higher marker question, so hence you have to pay special attention. So in this particular topic, what we are going to study is, it's all about what? Equations of motion by graphical method. So we have to derive equations of motion by graphical method. Now till 8th standard, what you were given is, you were directly given formulas. You were never told how those formulas came into being. Okay? So the way in which the formula are created, that is called as derivation. So from 9th standard, you won't be just given formulas, but they will also tell you how to derive them. And one of those starting points is 8.5, in which you will be given a way to derive 3 equations of motion. So 3 formulas you have to derive related to motion. So we will see first those, what kind of formulas those are, and then individually we will derive them. And what method we'll use? We'll use graphical method. Graphical method in the sense we'll use graphs for solving this particular equation derivation. So let us start. So what kind of 3 equations of motion are there? Now what is the meaning of 3 equations of motion? See, already we know what is motion. That is change of position with respect to time. And 3 equations means 3 formulas. So 3 formulas is related to what? Motion. So that is what we are going to study. So basically there are 3 formulas which you can use to solve any straight line motion problem. So any numerical which is given in your 9th standard based on straight line, you can use 3 formulas to solve them, and we'll see which those are. This is the first equation of motion. V is equal to u plus at. V is equal to u plus at, and it is also called as velocity time relation. Why it is called as velocity time relation? But you can see on left hand side there is velocity, and on this side there is time. So we are ignoring initial and acceleration. So this basically equation is relation of what? Velocity and time relation. Then there is second formula. Second formula is S is equals to ut plus half at square. S is equals to ut plus half at square. This formula is, what is the name for this formula? This is second formula, and name of this formula is position time relation formula. Okay, position time. Why position time? Because position is nothing but given by S. Position means what? Displacement or distance. So that is given by letter S, and hence this relation is between this S and the T. So hence it is called as position time relation. And the third equation of motion is v square minus u square is equal to 2as. V square minus u square is equal to 2as. And this relation is between what? Position and velocity. So you can see on one side there is velocity, on one side there is position. So that is position velocity relation. So what we are ignoring in all of these 3? Acceleration. So in the first case it was velocity and time. In second case it was about position and time. And in third case it was velocity and position. Okay? Now we will see what kind of these letters mean, like what is the exact meaning of these letters. So first, you already know u and v, you have an ample idea. U is nothing but initial velocity, v is final velocity, that you already know. Then we have a, that is called as acceleration, and t is nothing but time. The only thing which you don't know is s. So s is nothing but position. It can also represent displacement, or it can also represent distance. So basically s is nothing but position, displacement, or distance. So you do one thing in your notebook, just write down these 3 equations. V is equal to u plus at, s is equal to ut plus half at square, and the third one. And these remaining things, you please write it on the right hand side, that what is the name of this particular equation. Velocity time relation, second is position time relation, third is position velocity relation. Okay, I will give you some time, just write it down. Once you have written, let me know so that we can proceed. Okay. So what are the three equations? V is equal to u plus at, s is equal to ut plus half at square, and third is v square minus u square is equal to 2s. You have to memorize them. Okay, we are going to derive them, but you have to memorize these formulas. Very important. And by the time you practice all these formulas, you will memorize it. Don't worry, because in the initial moment you might feel that these formulas are somewhat tedious, but later on you will feel that these formulas are very simple to remember. Okay, v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2s. Now let us derive them one by one. So first we will derive is the first equation of motion. Okay, we have three equations, so we are going to derive first equation of motion, that is v is equal to u plus at. Let us derive that. And I already told you we are going to use graphical method. So this is the graphical method we are going to use. Now do not write down anything. You do one thing: whenever I say you to take the screenshot, you take screenshot afterwards. ठीक है, मतलब the complete derivation, because we cannot waste our time in writing down this in our notebook. But I told you already, the derivation is not given properly in our textbook, so hence you require this derivation, but you do not write it. You just take the screenshot afterwards, okay, when I tell you the complete derivation. Now focus on this. The graph which we are going to use to derive these three equations of motion is going to remain same. So same graph has to be used for all the three equations of motion, and that graph name is velocity time graph. Okay, so what kind of graph we are using? Velocity time graph. And you have to remember that you do not start from the origin. You do not start from the origin. You have to start from the top. Okay, you just move that origin point to somewhat above. What is the meaning of this line? The meaning is that it's a uniform motion, but it is not starting from zero. The initial velocity is not zero. That is the meaning. Because if u becomes zero, then how will we get our formula? So hence what we have done is we have shifted that line from origin to the above point, and that is the line we have drawn. Okay, you don't need to use color lines, huh? This is just for your understanding. I have drawn yellow line, blue line, red line. You don't need to draw this. You draw with your pencil. Okay, this is just for understanding. So which graph we are using? Velocity time graph, and a straight line which is not starting from the origin. Now first thing what we are going to draw is we are going to draw one perpendicular to the x-axis. So we are going to start from one of the ends. So we have drawn a perpendicular. Now second thing what we are going to do, we are also going to draw perpendicular on y-axis. I have given it a letter. You can see I have drawn a perpendicular and I given letter A. Let me draw a perpendicular to y-axis also. So I have drawn perpendicular to y-axis. Let me give a name to that as well. Okay, and I have drawn a third perpendicular from this. Okay, so I have joined from this to this particular line, and then I have given the letters to them. So this O is nothing but origin. I have given letter A here. You can give any letters, that is your choice. But I feel that O should be given to origin because basically it's an origin. And afterwards later you can change anything like A, B, C, D. I usually like to give them serially because then it becomes easy for us to write down equations. Okay, but it is up to you. Okay, that is not suppose hard and fast that you should be using the perfect letters, but it's up to you. I generally like to give them alphabetically. So A, B, C, D and E I have given. Okay, now once this is done, let me see what is our target. Okay, our target is first equation of motion, right? But before that, let me put the values. I already told you that this particular line is not starting from origin, so that means it has some velocity. Initial velocity is not zero in this case, so that means the value is not zero. So let me put that value. I will take that value as u. U means what? Initial velocity. It has some initial velocity, and time here is zero. And let me just say that at point A, the time is t seconds. Okay, I am not specifying how many seconds, like 5 seconds, 6 seconds. I'm just mentioning that from O to A, time is t seconds. And what is the velocity I'm saying at D is, it is u, initial velocity. And you can see that object has traveled and it has stopped at point C. So what I will do is, at point D, I will say initial velocity is u, and I will say at final point C, final velocity is v. So I will just take that value here. V I will represent at E, and at D I will represent U. And what about time axis? The value here is 0 and the value here is t seconds. So let me put that. See, what I've done is I have started from 0 second and ended at t seconds. I'm not mentioning how many seconds. I'm just mentioning one variable. You already always solve those algebra questions, no? Let the value be x. So in the same way, what I've done is on time axis I have taken t instead of taking a number. And what about velocity? So I have taken some initial velocity u, and final velocity, that is c value, is I have taken as v. Final velocity v, initial velocity u, 0th time and tth time. Now let us start with our target. Okay. Now, as you can see, this particular OABD is nothing but a rectangle. You can see OABD is a rectangle. So whatever the value of OD is, what is the value of OD here? U. So whatever the value of OD is, the same value applies for AB. Why? Because opposite sides of rectangle are equal. So that means OD is equal to AB. So whatever the value U here is available, same value would be available for AB as well. So OD is equal to AB is equal to U. What about the V value? Definitely C will also get the same value, V. But concentrate on this. If the total value of AC is AC, what is the value of total AC? It is V. And what is the value of B, AB? It is U. So this is U, total is V. So I can calculate BC. BC would be what? V minus U. Okay? So BC would be what? V minus U. How this we have derived? So see, total length OE is V, right? So that means AC is also V. After that, AC is equal to AB plus BC. That means if AB value is U and AC value is V, so BC value would be V minus U. Okay? I hope you are understanding this, how we have derived this. This OD is equal to AB. What is the reason? Opposite sides of rectangle. And how V minus U we have calculated? By subtracting total V minus U. Okay? So give me response in chat box till this time. Have you understood how V minus U has been derived and the other things? Fine with the letters? V minus U, U, everything. Can we proceed? Give me response, students. Without this, I cannot suppose proceed. Okay. So what we have done is, I will again explain you in a shorter way, but I'm not going to explain it again and again. Okay? So concentrate properly. Graph is velocity time graph. This line we have not started from O, so that means it has some initial velocity. After that, what I've done is, I have taken perpendicular from this point to the x-axis and then perpendicular to y-axis. So that is what I've done. Third thing what I've done is, I have taken perpendicular from this to this point. So that I will also draw. After that, I have mentioned initial velocity for this particular thing and final velocity that. But before that, I will just draw the letters. So A, B, C, D, E, F. I have given every point a letter I have given. Okay, a capital letter. So capital letter has been given to every point. After that, I will assign values. D represents velocity. You can see there is velocity here. So at point D, it would be initial velocity, that is U. So I have mentioned U, initial velocity. I have mentioned final velocity. I have mentioned the time, 0, because this is starting point. So time would be what? 0 here. And instead of mentioning a number, I have mentioned time as T here. So at point A, time is T seconds. Now let us begin. OABD is rectangle. So whatever the value of OD is, it would be equal to AB. Opposite sides of rectangle are equal. So AB value would also be equal to U. And what about the AC? See, OE is V, means this total distance is V. This is U. So this value would be v minus u, subtraction. So this total value is u. Above part BC would be equal to v minus u. Okay, so that is what we have got. Now let us start with our first derivation. Now our target is this formula, v is equal to u plus at. This is our target. So let us start. Now, if we want to find out acceleration, from this graph, what do you think we should take? Area or slope? Because in the formula A is present, acceleration. So what do you think? What should I do? With velocity time graph, should I take area or should I take slope? Give me response in chat box. Okay. Tanmay has answered first answer. He's saying is slope. Okay, right. Cabra, yes, correct. Fine. So, okay. So the first one to answer today was Tanmay. That is very much correct. To find out acceleration from this graph, we need slope. So definitely, if the in the formula if there is a, that means we need slope of this graph. So let us take slope. But for slope, we should take some points, right? We should know certain points, coordinates. So what we'll do? We'll take these coordinates. We'll take D and we'll take C. So let me take those. So I have highlighted those. Why? Because I am going to take slope of this graph. So I have highlighted those points, those coordinates. Now, what are the values of those? One would be called as x1, y1. One would be called as x2, y2. So the definitely x1, y1. But what is the value of x coordinate here? See, this coordinate is present on y-axis. So that means x value would be 0. And what about y value? Y value would be u. Y value would be u. Why 0 value for x? Because this particular coordinate is present on y-axis. Same in the same way, C would be having x2, y2. Its x coordinate is what? Let me see what is the x coordinate. X coordinate is t. And what about y coordinate? Y coordinate is v. Okay. So this is the coordinate x2 comma y2. T comma v. X coordinate is t. Y coordinate is v. So we have got our two coordinates. Let us take slope. Now what is slope? Slope is nothing but delta y by delta x. But that also means whatever is present on y-axis divided by whatever is present on x-axis. So slope is equals to velocity by time. Why? Because velocity is present on y-axis. So y by x is equal to delta y by delta x. But you already know what is the physical quantity which we can get by velocity by time, that is acceleration. So acceleration is equal to delta y by delta x. From the slope we received velocity by time is equal to delta y by delta x, but velocity by time is nothing but acceleration, and remaining part is delta y by delta x. Now how can we change this delta y and delta x? What is the meaning of delta y delta x? Delta y means what? Y2 minus y1, and delta x means what? X2 minus x1. So let me put those y2 minus y1, x2 minus x1. So these are the things which you receive. Now you already have the values of y2, y1, x2, x1. You already have those coordinates, right? Just put them. So I have put those values. A is equal to y2 value is what? V. I have put v. Y1 value is what? U. So u I have put. X2 value is what? T. So I have t I have put, and x1 value 0. So that value I have put. But there is no meaning for 0. So this equation will become A is equal to v minus u by t. So this equation has become v minus u by t. Why? Because 0 has no value. Now, what I will do is I will rearrange them. I will transfer this t to the other side. This is in division here. After going towards a, it will go into multiplication. So new equation will become what? This t I have transferred to a, no? So this particular equation. Let me transfer that t to a. So this is what I have transferred. I have transferred that t to a. So it has become at is equal to v minus u. Now focus on our formula. See, it is almost like our target formula. Our target formula is v is equal to u plus at. This is what we want. This is our target. And what we have got is at is equal to v minus u. Now all you need to do is transfer this v to the other side. U is in, like, subtraction here. After going to that place, it will go into addition. So just transfer that u to the other side. It will become v is equal to u plus at. V is equal to u plus at. So you can see this is our formula. This is what we required, and this is our formula. V is equal to u plus at. So give me response in chat box. Have you understood till this moment how we have derived it? Like how we have taken slope, how we have changed it to delta by delta x, and how we have substituted values. Okay. Now what I want you to do is take a screenshot of this. Take a screenshot of this, because if we just try to write it now, it will become very much what I can say. It will consume our time, and we don't have that kind of luxury. We have to also cover remaining two. Okay. So take screenshot if possible. If it is not, I will also make it available in the description. Okay. Whenever I will upload it on the YouTube, I will, in the description below that video, I will make this image available. So don't worry. If you have a screenshot option, take it. Otherwise, I will make it available. Don't worry. Okay. Samruddhi, what you are asking, we have to write it afterwards. Definitely, please write it. See, I am not asking you for on purpose, but problem is that this derivation is not correctly given in textbook. It is very much confusing, and one student cannot, memorize it and write it. And this question is asked again and again in the exam. So I want you to have this as a proof for your, what I can say, preparation. I want you to have this. Okay, so everybody is supposed to write it in a notebook for their own exam preparation. Now let us go for the second equation derivation. Okay. So what is the target? Target is S is equals to ut plus half at square. That is our second formula. We are not going to change our graph. Graph is going to remain same. But focus now. Value which we require here is S. Okay. And from velocity time graph, if we want to find the value S, which means displacement or distance, we need to take what? Area. So area we have to take of this graph. Why? Because S is present. We cannot get S value unless and until we take area. So let us take area. How to take area? Area is nothing but y-axis into x-axis. So that means velocity into time. So area is equal to velocity into time. But you already know what is one quantity which we can get by velocity into time. That is nothing but displacement. So that we already know. Area of this graph is nothing but displacement. Let us proceed further. This displacement can be represented by which letter? S, that we already know. So we have taken area. For the second equation, we have taken area. Now let us proceed. This S is nothing but area, right? This S is equal to area. You already know. We have found that area is nothing but displacement, and displacement is nothing but S. So this means S is nothing but equal to area. Now, if we want to calculate area of this particular diagram, that is OACD, whatever is present below this yellow line, that area we have to find. So below that yellow line, two geometrical figures are present. One is a triangle. You can see one triangle is present and one rectangle is present. So the triangle is nothing but DBC, triangle DBC, and that rectangle is OABD. OABD is the rectangle, DBC is the triangle. So let me just add those. We already know how to calculate area. So area is nothing but rectangle area plus triangle area in our case. So how to find out rectangle area? Rectangle area is very simple. All you have to do is multiply length into breadth, and for triangle you have to multiply 1 by 2 base into height. So let me do that. Area of which triangle? Rectangle we are taking OABD we have taken. And what about triangle? So for triangle we are taking DBC. Let me put the values. We can just multiply. What is the value of this OA? OA value is T and this AB value is U. So U into T, we will get area of rectangle. Okay. So let me put that. U into T is nothing but rectangle area. Why? Because you can see OA is the length, AB is the breadth. So that means all you have to do is multiply OA value, which is T, multiplied with AB value is U. So T into U. That is the thing. And for triangle, 1 by 2 base into height. Base is what? Of this triangle, base is DB. And what is the value of DB? The value is T. So I have put 1 by 2 base, that is T, into height. What is the height of this rectangle? Sorry, this triangle. So that height is V minus U. So I have put V minus U also. Okay? Give me response in chat box. Understood till this moment? We just have added the areas. That is what we had actually done even in our sample questions. Right? Okay. Now let me add those. What is t into u? That is ut, and plus half into t into. What I'm going to do is I'm going to substitute the value of v minus u. Okay. So let me show you how to substitute the value of v minus u. That is very easy to do. You already know what is acceleration. Acceleration is nothing but v minus u by t. That is nothing but change in velocity by time. Okay, rate of change of velocity. But if you want to find the value of v minus u, just this bracket, I have to move this t to a. So just move that t to a. It will become what? V minus u is equal to at. So I can substitute the value of v minus u with at. So I will substitute that value here. So equation will become s is equals to ut plus half into t into at. So that equation I have changed, ut plus half into t, and v minus u bracket is becoming at. So I can put that. Now I can multiply t with at, it becomes at square. So s is equals to ut plus half at square. S is equals to ut plus half at square. And this is what our target was. See, you can see the formula. We wanted s is equal to ut plus half at square. And that is exactly what we have got. Okay, so what we did, first we took area, that is displacement, then we added rectangle area with triangle area, and then we substituted the values. And we also substituted the value of v minus u. Okay, so give me response in chat box. Have you understood this? How to derive the second equation of motion? Okay. And what I want you to do is, see, some students tend to get confused while deriving these equations because they have not understood the previous points about area and slope. So if there are certain students who are not understanding, suppose let us say how we are deriving this, that means they were absent, either absent for those slope area graphs, or maybe they have not completely understood it. So what I suggest for those students is go through those videos again, though those are already uploaded on the group. Understand area, understand how to find slope, and then only you will understand this particular derivation. Unless and until you understand area and slope, you cannot derive these formulas, okay? And you won't even understand how we are deriving it. Now the third one we are going to derive now is the v square minus u square is equal to 2s. So let me show you how. But before that, we have to see area of trapezium. Okay? So this is a basic figure which you have already gone through in standard 8. So if this is a trapezium, and if you want to find out area of this trapezium, so trapezium has two sides and those are parallel. So you can see PQ and SR. Trapezium consists two parallel lines and two non-parallel lines. Okay? So in this case, PQ and SR are the parallel lines. And what about the non-parallel lines? These are the non-parallel lines. PS and QR are the non-parallel lines. How we can find out area of this? Area of trapezium is nothing but 1 by 2 into sum of parallel sides into the distance between them. That is the formula. Okay? This formula you have already studied in class 8. Okay? This is something like length into breadth for area. In the same way, area of trapezium formula is 1 by 2 into sum of parallel sides into height. And what is the parallel sides here? One is B, one is A. You can see. Let me put those values. So area of trapezium in this case is 1 by 2 into B plus A into H. Okay? The distance between them, that is the height. So this is the formula for area of trapezium. Now, we are going to use that area of trapezium for calculating the third equation of motion. Okay, we have to derive this. So what is the target equation? V square minus U square is equal to 2s. We are going to use the same graph. And we are going to take area only. But do remember, we are going to change area this time. Last time what we did is we added this rectangle area with triangle area. But this time we are going to take a combined figure. We are going to consider D, O, A and C a figure, and that is exactly a trapezium. So we are going to calculate area this time with the help of area of trapezium. So let me take area of this graph. Area of this graph is velocity into time. That we already know. But velocity into time is what? Displacement. That we have seen in the last equation also. And that displacement is equal to S. So everything we have covered. But this time we are going to make only one minor change. Instead of taking area of addition of rectangle and triangle, we will say we will take the complete area, and that figure is nothing but a trapezium. You can see D, O, A, and C. This is a complete quadrilateral, and this is exactly a trapezium. So let me highlight it for you. This figure. This is area of trapezium. Okay? So we can just take area of trapezium for the third equation. And what is the formula for area of trapezium? 1 by 2 into sum of parallel sides. Now in this case, which are two parallel sides? DO is parallel to AC. DO is parallel to AC. And what is the distance between them? You can see DB is the distance. So DB distance है, DO and AC are the parallel lines. So let me put the formula 1 by 2 into sum of parallel sides. Which are two parallel sides? OD and AC. So OD and AC. Sum of parallel sides. So sum कर लिया मैंने into height. What is the height between them? That is DB. So into DB. We already have the values of OD, AC, and DB. Let me put those. What is the value of OD? U. And what about AC? V. So U and V. And what is the value of DB? That we already know, that is T. So every value I have put. S is equals to half into U plus V into T. So give me response in chat box. Till this moment, have you understood how we have derived S is equals to half into U plus V into T? We have used the formula of trapezium. Understood till this moment? Okay. Now let us proceed. What we are going to do now is S is equals to half into U plus V into T. That is what we have got in the last step. We are going to take it further. You can see it is S is equals to half into U plus V into T. So I can use the value of, suppose, acceleration. I have to change this value. I have to take this T value. Acceleration is nothing but change in velocity by time, V minus U by T. So I can say T is equal to V minus U by A, right? I have taken T here, I have substituted A here, and I am going to replace the value of T here. So T is equal to V minus U by A. So value is S is equals to half into U plus V into, what is the value of T? V minus U by A, V minus U by A. Now what I'm going to do is I'm going to take this A and T 2 to the other side. 2 and A, I'm going to take it to the S side. So that is what I've got. I have shifted 2 and A to the S side. So two brackets I have got U plus V and V minus U. But you already know A square minus B square is equal to what? A plus B and A minus B from your last year mathematics. A square minus B square is equal to A plus B, A minus B. And these are the two brackets. So in place of those, I can write down 2as is equals to V square minus U square. V square minus U square. And that is what we wanted as a formula. 2as is equal to V square minus U square.